Hello, this is Larry Rowland from Lehigh White Cement Company. I want to thank you for your invitation to have me be part of the Thailand Concrete Association's 16th Annual Concrete Conference. I'm with Lehigh White Cement Company out of West Palm Beach, Florida, and I'm pleased to be an ACI ambassador to the Thailand Concrete Association. Today, I want to talk about meeting design goals with architectural concrete. And I'm going to be using a really exciting, beautiful project, the REACH, which is an expansion project at the Kennedy Center for the Performing Arts in Washington, D.C. One of the things that people don't understand about architectural concrete is they tend to think that because it's beautiful, it isn't necessarily a structural material. Nothing could be further from the truth. Architectural concrete is just as strong, as long as it's designed correctly, of course, it's just as strong as any gray concrete. It meets the same specifications. It has the same basic materials in its makeup, and it tends to be higher consistency, and it takes more effort to achieve that consistency. So, in general, it tends to be higher quality because the effort taken to improve its consistency will necessarily make it its performance a little bit better because people are paying better attention to the material. So some examples of just how strong architectural concrete can be. There are architectural precasters who cast high performance mixes every day. It's what they do as their standard business model is they're producing high performance architectural concretes. And of course, you can also make ultra high performance concrete with white Portland cement as the base material. We actually produce a UHPC with the Aalborg brand that meets these characteristics. UHPC will have minimum 28-day strengths of 120 MPa to 150 MPa, 17,500 psi, or 22,000 psi, depending on the application. Another good um, example of where architectural concrete is made for structural performance is the REACH at the John F. Kennedy Center for the Performing Arts. You can see that Vulcan Materials, the ready-mix concrete producer for the job, produced different mix designs based on different applications that meet 6,000 up to 12,000 psi concrete. So definitely a very high performance concrete here at the REACH in Washington, D.C. Another example is the Western Hemisphere's tallest residential building. It's 432 Park Avenue, is a high rise in near downtown New York, right off of Central Park, Park Avenue, of course. This project is 1,400 feet tall and utilized 14,000 psi concrete. It was self-consolidating concrete that was pumped all the way from the ground level up to the top of the structure, 1,400 feet high, and it's just a real testament to architectural concrete that it was able to be used in this highly structural manner and high performance application. When we're talking about architectural concrete versus standard gray or just plain Jane structural concrete, um, the three things that we focus on are going to be color, form, and finish. And so the color for a specific project will predominantly come from the material itself. So the concrete itself, the color is going to be dictated by the raw materials that you use to make the concrete, and then the application of the concrete in place on the site and how the light will affect that different aspects of the project will certainly affect the way it's viewed, and it's something important to look at. You can see this beautiful reflecting pool at the REACH at the John F. Kennedy Center for the Performing Arts, where the architect anticipated the views and has really produced just a neat project to visit and to inspire people about John F. Kennedy Center for the Performing Arts. The other thing that you want to look at is your form. In other words, what is the concrete relief all about? What is the texture of it? That's going to be in the mold or the forms, as we call them. And you can use different form liners to give you that different texture and give you that different profile for the face of your concrete. And these forms can be very complex or they can be fairly simple. And the more complexity tends to drive up your cost. So, look at the budget and what you can afford, and then you can make adjustments from there. The finish predominantly talks about essentially how much of the matrix of the concrete that you're actually going to see. Is it just the form finish, which is that paste edge, the very face of the concrete, or have you eroded the face away of the paste and that hard form finish and gotten back into the fine and coarse aggregates to reveal the matrix from underneath? Um, Architectural concrete is a balance. So you're going to look at those three different things: the color, the form, and the finish, and you can adjust those to give you different looks here. As we talked about, the mix establishes the color. The form or the mold is going to give the concrete its permanent shape, and then the finish is going to give you that visibility of the matrix. By adjusting those different uh, materials or the form and the finish, you can get a tremendous variation, which will give you an artistic or an architectural effect. The neat thing about architectural concrete is it's very sustainable because you're making the concrete material itself be the finish, be the material that you want to see. So you don't have to coat that with something that won't last nearly as long. You're going to make that concrete the final product. And so utilize white cement for bright colors. Choose supplementary cementitious materials such as slag or metakaolin. They're a light color when you want to get a bright color. Uh, Make sure that you're choosing the correct aggregates to complement your mix. And then, of course, you're going to end up with a very strong, resilient, long lasting material, which, of course, is a baseline for green building and sustainability. So here's a typical mix design from North America. As you can see, the, the paste portion is what's going to dictate your color more than anything else. So the paste is going to be the combination of the cement, supplementary cementitious materials, pigments, any pigment that you add to the concrete, very fine aggregate particles, essentially the dust from any of the aggregate that you have in the mix. All of these combine to color the paste. The paste will give you that background color. The paste goes everywhere and coats everything. And so it will give you the tone or the look of the concrete overall will be dictated by the paste portion of the mix. And then after the paste, the which is dominant, by the cement and the other fine materials, comes the aggregate. First, the fine aggregate, which is sand, and then the coarse aggregate will affect your color from there. The Reach project at the Kennedy Center utilized a white sand from Maryland, which helped complement the white cement and the other materials to give it that marble-like finish. Um, for architectural concrete, it's important that you choose the right supplier. So for cast in place, that's going to be the ready mix supplier. Vulcan Materials was the concrete producer, ready mix supplier for this project. They did a terrific job. They have a lot of experience with architectural concretes, and they had the ability to use a plant that they could reach the project that they could isolate and specify only produce architectural concrete for this job, which so that kept the cement all the same, the raw materials the same. They didn't have to worry about contamination, and it really gave them a leg up on the project to produce this job. The other neat thing that's important about choosing your producer is the experience they have. Like I said, our Vulcan has a lot of experience with architectural concrete. They have intimate knowledge of the local materials and the types of mixes that they're able to produce, and the different effects that those colors will get for them. Um, so it's important as the designer that that you manage your expectations and that you set your expectations based on that local experience, based on what aggregates are available in the area, and then make sure that you work with your suppliers and let them know that you're going to want to do multiple mock-ups, perhaps, or different test pours to make sure that you're going to test out and prove out what those mixes should look like. The other thing that you want to make sure about that producer is that they work with their drivers and the different people who are involved with the project. You want to make sure that the trucks are clean. You want to make sure that they're only hauling that architectural mix or a light colored mix. You don't want to have them go straight from a gray job and then try to produce an architectural job without a thorough washing of the truck. Same thing with any of the equipment that's going to touch the concrete. You want to make sure that the pumps are clean, that the forms are clean, and that the um, contractor who's going to be placing the concrete understands the requirements for the aesthetics that you're trying to achieve. Make sure that they understand that you're trying to get an architectural concrete, so the color is important. So they have to treat it specially. They have to be careful, make sure they're not dragging any contaminants into the concrete, et cetera, and keep it clean essentially. So the mix design, like we talked about, will set your color. Um, the paste proportion of that is the most important part of it. Once again, um, you have to sometimes do trade-offs. So for this Kennedy Center, they have green building targets. This is going to be a certified lead job, and so it's important uh, that the mix had supplementary cementitious materials. And so the color at the reach, they started with white Portland cement, Aalborg Portland type 1 cement, uh, and that very consistent, um, very reliable color for that project. They added slag. Some of the mixes had up to 40% slag in there. The slag is a light colored, almost white supplementary cementitious material. It is a little bit off white. So when it was combined with the local sands available to the project, they found that they wanted to brighten up that mix just a little bit more. The mix was about 85% of the way there. They added titanium dioxide to get it the rest of the way to the bright white that they finally achieved and that they wanted to use on the project. Titanium dioxide is just a white pigment used to do that. Pigments are very strong coloring agents, and they can really help take you to the next level as far as colors go. So just a kind of a break here in the narrative, it is worth mentioning that architectural precasters, I talked briefly about them at the beginning, they have some advantages over this that could be useful to the architect. You can see they have very experienced crews that deal with architectural concrete all the time. They have very good control. They understand, they're working with it every day, so they understand the different procedures that they need to take to make sure that they protect the color of the concrete. And it can simplify the owner's or the specifier's role, because essentially that owner or specifier can choose a color and a finish, and then just leave it to the architectural precaster who will do the rest. A lot of the guesswork is taken out of it. And of course, you can see here, just this is a crew that does it every day, so they know how to give you the architectural concrete that you want. So whether you're using a precast or a cast in place application, the form finish and the things that make a form finish the way it is the same. So um, that form or mold finish highlights the paste. Remember, it gives you that very crisp, clean lines. It's going to have a very smooth, tight, dense appearance, and the concrete is going to show you everything that is associated with that job. You can see the form liners. The architect developed this what they call crinkle concrete that they use for acoustic relief and help break up the sound within some of these different performing venues within the Performing Arts Center. You can see here's the form liner. I'm not sure if you can see my cursor, but there's square pattern on that wall that's facing us. You can see with a taper tie hole, etc. There's minimal penetrations in this wall, and this is a very dense, solid surface. You can also see that the slag, in this case, in some of these uh, on some parts of this wall, you can see that slight bluing color, that darker color. That's the slag before it is oxidized out. That discoloration will typically go away. Um, and where you need it to be white, typically you can just reduce the amount of slag, and or if you don't need to have the slag in there, you don't have to worry about that bluing effect from the ground granulated blast furnace slag. The form will be the result that you're going to get. In other words, that whatever the inside, the face of the form is up against the concrete, that's going to give you a true representation when you strip it. So form liners can give you all kinds of dramatic effects. The architect at the Reach chose this rough cut Douglas fir strips of wood that gives you a very neat kind of a natural texture to the walls. It's really very effective, very pretty when it's all put into place. Um, and really, as far as whatever you're going to line your forms with, there's no limit to it. It's all what you want to make sure is that the materials should be non-absorptive, um, and that you can afford them in your budget, essentially. Um, one of the things to consider is the depth of the relief. If you have very deep patterns, it can become more difficult to strip the forms, and you also have to make sure that the clearance for any reinforcing from the surface is a good 2 inches behind the deepest part of your form liner. So make sure that you consider those. You can utilize stock form liners or customized. You can see this is the custom pattern that was achieved using those strips of wood on the inside of the forms is really very telling. It's very neat to see. Um, we talked a little bit about mock-ups. We'll talk about them over again because it's so important to evaluate ahead of time what that surface is going to look like. Here's some images of some small mock-ups that were done for different kinds of layouts for the wood and different forming oils and stripping materials used to make sure that they achieve the look that they're trying to get. So make sure that you utilize mock-ups and test pours effectively, and that'll get you the project that you want at the end of the day. So the concrete is cast in. Once you cast that wall and you've stripped the forms, you're pretty much done. So the mock-ups give you a trial, an opportunity to test out different mixes and to evaluate the color and the look that you're getting, and then it also helps you, um, plan ahead for how you're going to address openings, how you're going to address joints, etc. Those should all be specified as part of the mock-up. You want to make sure that everyone in the project knows you're going to be doing mock-ups and what's expected. You want to have all the different kind of things that will be encountered at the project itself to be represented in that mock-up, and that gives you an opportunity to see how you're going to treat different conditions within the jobs. Another, it's important to try to basically have some flaws in the mock-up and show how you're going to do some repairs, because how you're going to achieve a good-looking job at the end is important to detail out. So the role of the architect, besides having that vision of what the project will look like, is to make sure that you specify, um, what the texture was going to be. Uh, or do you want to use form liners? Don't you? What colors you're trying to achieve? Identify the finish. Ask for examples. There are many different architects may be able to point to projects and examples of different features that they can give you from previous projects, and then make sure that you engage with the engineers, because um, it's a lot easier sometimes to draw something on paper than it is to produce it in real life. So it's important to have that specified as well and get the engineers involved. Um, think about how hard it is going to be to um, form up the wall and strip off the forms when you're done. And then, of course, as part of that overall effect, is to think through how the water's going to be handled on the project. Make sure that you're not, that you carry away any waters, or you provide a drip edge so that you're not carrying any pollutants or any dirt or soot onto the face of your concrete. Make sure that you've taken care of that so that you don't end up with a place where the water runs down and carries, a stain essentially onto the face of the face of the job. In the finishes, the form finish, like we talked about, will give you that hard, dense look to it. If you expose the matrix, it'll give you a different texture, a different feel. It can certainly affect the color. One of the ways that we do that is with sandblasting. There's a light blast to the right side of this image, and then a medium blast on the left, medium to heavy. You can also achieve these kind of finishes with chemical retarders. Basically, form oils or form release agents can be made so that they will etch the surface. As you strip them off, you can then wash it down, and you get this exposed matrix to the concrete. You can acid etch it, or you can also do mechanical tooling. You can bush hammer it, you can polish it, etc. Sandblasting is very common in the precast industry because they have essentially a factory setting where they have a designated area where they can do the sandblasting. Uh, Typically, medium blast is the most forgiving and the most common specified type of finish. It will expose the sand and a little bit of the coarse aggregate. It typically will not get very deep into the panel to expose the aggregate. You want to have just a little bit showing of that aggregate typically, and it leaves a slightly roughened surface as opposed to the form finish. You get like a sugar cube or a sandstone kind of a feel to it. Like we talked about, the form release agents, the different suppliers can give you various depth of etch according to the different form release that you've specified or that's been used on the project, and that will give you different levels of exposure of the matrix. It's important that the contractor use a non-staining form release. Make sure that that is part of the description of the project when you're writing your specifications. It should be applied the same way every time. Typically, these are applied at very thin layers onto the forms, and that will achieve the best performance, the most consistent look to that concrete. Self-consolidating mixes tend to be easier to place. Make sure that the ready mix supplier, the concrete supplier, has a good technical background to control these mixes. They rely on chemical admixtures to get them to these high slumps, and so they tend to be a little bit more technically challenging. And it's important that the control is there. The contractor, of course, has a very large role in placing the concrete. You want to match the mock-up every time. You want to make sure that there's good technique with the vibration of the form, vibration of the concrete within the forms, and or external vibration of the forms themselves. The other thing that's important is you want to have an uninterrupted pour. In other words, from beginning to end, you want to make sure that there's no delivery issues so that the concrete is there when you need it so that you won't have a cold joint. Plan for breaks in the sequencing of the concrete. If there's a joint where you want it to be, everyone can prepare for that and build it into the project as opposed to being surprised because trucks were delayed or you had some other issue. And then sacking and patching after the fact um, can be a real art. Working with that's why you want to make sure that these conditions are shown in the mock-up. How are you going to go and do any repairs or fill any tie holes, etc., on the project? So it's important that we start with a vision. Um, Here's an excellent example of that at the Reach at the John F. Kennedy Center for the Performing Arts. Stephen Hull Architects had the vision for this. Just a tremendous project. You can see that they combined the practical application of accommodating a lot of different performing arts venues within the project and the need to provide a welcoming, open a place for the public to be engaged, and then also take care of all the needs for all the different kinds of places that are there. The what you see here is almost like a park light setting is actually green roofs that have basically a park on top of them. Underneath the ground, there's everything from parking to different classrooms and venues for performances within that project. They did an excellent job of understanding the materials and how to get the look that they wanted. And of course, this project, like we talked about, has sustainability goals that we expect to be uh, met with a certification by LEED. Um, so the engineers and the architects got together and they determined that to have that park-like setting, which is the green roof on top of the different parts of the project, that they would want to lighten the slab. So they basically wrote it into the specifications and the description of the job. They put it in the plans that they would lighten the load of the concrete to accommodate the load of the park-like above. And if essentially one of the things that's important to remember is that if you don't put it in the specification, it won't be in the job. So you have to make sure that the specifications are going to outline exactly what you want and how you intend to get it. And at this project at the Reach, one of the ways they did that is by lightening the slabs using these voided slab systems. The other thing that they did is they specified that they wanted to have minimal penetrations in the walls, that the walls needed to have a finished look and that external bracing was going to be widely used for the formwork. Minimal ties inside the wall between the forms, and where they were left in place, they tended to be stainless steel to make sure that there would be no staining in the future. And those external braces were used like to great effect because these walls were so tall and that they were self-consolidating mixes. You had very high form pressures up to 18,000 psi form pressure. So special materials, special techniques that were engineered ahead of time to make sure that the walls that they achieved, that the project that they were casting achieved the goals that they had in mind. The other thing that is important to do is include the owner as a member of the team on this. So the John F. Kennedy Center for the Performing Arts was the owner of this job. They were highly motivated. They had the vision that the architect had presented. They understood it, and they were able to work with the architect to solve it problems, to address issues as they came up. And because they had the same vision, they were able to work with them and make sure that this job happened in the way that they wanted. And so they got the end result that they were looking for. They have structural application of architectural concrete, and They are very much, uh, you know, solving problems with engineering, not taking guesswork. Um, they were managing expectations. This is a very good role for the contractor and the engineer to work with the owner to make sure that they understand the cost of what it's going to take to achieve a vision and to see it through. Because if you know how you're going to address a problem ahead of time, you're going to know the cost and you can anticipate that and plan for it and make decisions and trade-offs as you go. So it's certainly a great idea to engage with the all the team members early, talk through the issues, make sure that everyone understands the overall effect that you're trying to get. Um, One of the things that we can applaud uh, the builders of the Reach and the JFK Center for the Performing Arts is how they were able to uh, combine engineering solutions to achieve those those architectural effects that they were looking for. It's both practical and beautiful at the same time. Um, they evaluated their environment, what they wanted to achieve ahead of time, and then they used all three elements: color, form, and finish to come up with a really stunning project. So they chose white cement because they wanted a clean, bright finish. Of course, it's a white color, so it's very bright and it's very consistent because the cement doesn't change color. White cement is going to be very consistent and it's going to, of course, be very strong and it will complement the fine aggregates that were chosen for this job, a white sand. Um, and it really is just a terrific project. Our hats off to the whole team involved with building the Reach at the John F. Kennedy Center for the Performing Arts. Thank you to those team members that help us understand how they achieved this. And I just want to thank you guys for your attention. And we appreciate the opportunity to discuss this really neat project. Thank you very much for listening.